right, ladies and gentlemen, we are going to talk about improper fractions. Um, an improper fraction is a number that has a larger numerator than necessary. I like to think of it as I had a super tiny student last year. You guys probably know her. She was in Rainbow Room, and she is named Mayrita, and she's just a very tiny person. Everything about her is smaller scale, and I'm monster huge. I'm like Godzilla. And so I used her as Mayrita as my example last year, and I said, yeah, an improper fraction is the same thing as Mayrita giving me a piggyback. I'm too big to be sitting on her shoulders. I will crumple her to the ground. So an improper fraction means that the larger number is on the top as the numerator, and the smaller number is the denominator on the bottom. And it just looks weird. And so we don't like to see improper fractions. They're kind of a weird thing, and they just look wrong, right? We're used to seeing proper fractions. So we're going to look at what makes an improper fraction improper. So Mr. Williams has some strips of wire. The wire is measured in 1/3 meter units. So here's the first one. This is 1/3. Then he has 2/3, right? If he adds another, he added another one to it. Then he has 3/3. That's equivalent to 1 whole, isn't it? Right? If I have all three out of three, I have 1 whole. Now he has 4/3, right? And that's equivalent to 1 whole and 1/3. And so as an improper fraction, it's written 4/3 or 4/3. So look at strip D. It is 1 1/3 meters long. There are 4/3 in 1 1/3. So 1 1/3 equals 1/3 plus 1/3 plus 1/3 plus 1/3 equals 4/3. Right? So these, if you see it on a number line, if you looked on a number line and you had 0 to 2, and you had 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, these are all improper fractions because they have a larger number on the top, right? And so they're called improper fractions. And that's why we have mixed numbers, so that we don't have to look at improper fractions. All right, so let's look at this picture. There are 5/3 in 1 2/3. So this is a drawing, a diagram, a model that's showing us 1 whole and 2 out of 3, 2/3. And if you were to count each of the thirds, we have 1/3, 2/3, 3/3, 4/3, 5/3, right? If you counted each little segment, if you didn't count this as 1 whole and you counted it as 3/3, then you would have 3/3, 4/3, 5/3, right? So there are 5/3 that are shaded. So 1 whole circle and 2/3 of a second circle are shaded. So it's more appropriate to say 1 2/3. But it's also correct, we can say this is 5/3 because there are 5 out of 6 shaded, right? And they're thirds. So we can call it 5/3. When you write your answers in math, you never want to leave an improper fraction. You always want to convert it to 1 2/3. Okay, so we're going to look at number 1, and I'm going to fold my paper first, and I'm going to do my usual 2 hamburgers to do my fold. It's lunchtime and I'm kind of hungry, so I'm not sure I should be talking about hamburgers. Okay, so I'm going to go ahead and write my name in the corner. And this is lesson 6.4. Plus, I keep hearing the ice cream man. That's making me hungry too. And we're going to do pages 258 to 261. All right. So we're looking on 259, and it says find the missing numbers and use the models to help you. So this is number 1. I have this circle and this circle. This one's divided into fourths. This one is also divided into fourths. And I'm going to use my colored pencils because I think that will help a little bit for you to see. So I'm going to... I don't really have... Do I have a purple pencil? It says I have a purple pencil, but I don't think I do. I think they're blue. So I'm going to pull out a colored pencil. Oh, it says violet. And I'm going to shade in what is shaded in the math book, which is 1 1/4. So this says there are green box in 1 1/4. So if I count how many fourths there are, I'm going to count this one. That's 1, 2, 3, 4, 5. So there are actually 5 fourths. Now, if you squint your eyes, you can see that this is 1 whole and this is 1/4. But if we want to write it as an improper fraction, there are 5 fourths in 1 1/4, right? So down here below it says 1 1/4 equals 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. And that equals 5 fourths, right? So we've represented each one of these little chunks. Okay, let's look at number 2. Number 2 again has 3 circles. I'm going to make them a little bit smaller because there have to be 3. And they're divided into fifths. And when you make a fifth, you make like a little stick person. So you go to the middle. You kind of find the middle of all 3. And then you go down. Then you go out with arms and legs. Out with arms and legs. Out with arms. It's like a stick person and legs. Not too bad. Now what they're showing us is they have orange. So I'm going to get out my orange, and what I'm seeing in the math book is this is shaded and this is shaded and 2 of these are shaded, right? With orange. I didn't color them very dark because I still want you to be able to see the lines. And then it says there are green box, and these are fifths, right? In 2 and 2/5. So how many, if you were to count out how many fifths I have, count them out for me and see what you get. I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I get 12 fifths. That's a really improper fraction. This is Marita underneath the weight of Karen. Piggybacked. So that's the same thing as 2 wholes and 2/5, 12 fifths, right? So if we were to write that out, if they made us write it out this way, we would have to write out 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, right? We'd have to do that 12 times. So thankfully they're not making us do that. So we know that 2 and 2/5 equals 12/5. Right? Okay. So in the book, it has another little example here, and it says, here's another way to think about improper fractions and mixed numbers. How many halves are there in 2.5? Well, if you look at it this way, it's a little hard to figure out, but if you chop these into pieces, then you have 1, 2, 3, 4, 5. You have 5 halves, right? So 2.5 is the same thing as 5 halves. That's a good way to think about it. Okay, so number 3 is asking us, we're going to do 3. 3 is asking us to express each model as an improper fraction. So this time we have squares. And the squares look like we're going to play Foursquare. They're divided into squares. The squares are divided into squares. And this one is shaded orange completely. And then it looks like we have 3 that are shaded orange over here. Right? So if we were to write this, we could say there are green box, and we probably want that to be fourths in. This looks like 1 3/4. So how many would we have? 1, 2, 3, 4, 5, 6, 7. So we would have 7/4. So we could say 1 3/4 equals 7/4. Okay, let's look at number 4. Number 4, we have some triangles. We have 1, 2, 3. And they're divided in half. And this one says there are green box halves in, and then we have some shading happening. I put my purple pencil away too early. So we have actually all of them shaded. That's interesting. So if we have everything shaded, and this, if they're all shaded, that means I have 3 whole number 3 triangles, right? So how many halves do I have? 1, 2, 3, 4, 5, 6. So this would be 6 halves equals 3 wholes, right? And that makes sense. If we had 6 halves, we put them all together, we'd have 3 whole triangles. Okay, let's look at number 5. Number 5 has some pentagons. And so there are 2 of them. So we're going to go boop, boop. A pentagon is like a little house. Boop, boop, boop. Boop, 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 boop. One of my houses is a little small. Again, we find the middle. And we go down to the middle. Arms in the air, legs out. Down to the middle, arms in the air, legs out. So it's like a little stick person. And these are brown. So I have 1 whole shaded brown, and then I have 3. So if I were to write this as a mixed number, I would say there are this looks like 1 whole, and this looks like 3 out of 5 to me. So that means I'm going to count the number of fifths I would have, and I have 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5. Can't even say that. 8/5. 8/5. Okay, we're going to do the little hands-on activity, but we're not really going to do it with a partner. We're just going to take those 4, and I'm going to do them on the back of my paper. So we're going to draw a picture of each one of those 4 things that we see. So we're going to go like this, and we're going to draw a picture in each one of the 4 quadrants. Okay? All right, and I have my colored pencils. So my first one that I'm going to do, the card says 5/3. The second one says 5/4. The third one says 8/5. And the last one says 7/7. It's a hard one to say too. So I'm going to be easy on myself, and I'm going to use my favorite color, green. And I'm going to make a rectangular model because I really like using fraction strips to show this. So I'm going to go like this, and I'm going to show thirds. So if I color all of these in, I have 1 whole, or I have 3/3, right? So in order for me to have 5/3, I have to go like this and draw another fraction strip like this and this. And I'm going to have 2 more, right? So now I'm showing 1, 2, 3, 4, 5 thirds. And 5/3 is equal to what? 1 whole, right? This is 1 whole, and this is 2/3. So it equals 1 2/3. Does that make sense? Yes, it does to me. Little Karen used to always leave class to go to the bathroom whenever we started doing fractions. So I struggled with fractions for a long time because I just didn't like them. And I wanted to pretend they didn't exist. Now I kind of like them. So if my denominator is 4, that means I'm going to have fourths, right? So I have to have 4. And if I have 5 out of 4, I know I'm going to need more than 1 strip. Right? So I'm going to go like this, and that's 4/4, right? Or 1 whole. And now I need my 5/4. So this is going to be 1/4. So I know that 5/4 equals 1 1/4. So 5/4 is the same thing. If you squint your eyes, that's 1 whole, and this is 1 out of 4. Okay, let's do the next one. Do I dare pick yellow? Can you guys see yellow if I pick it? Here we go. Now I need fifths. And I know I'm going to need, if I have a bigger number on top, larger than 5, I know that I'm going to need at least 2 of these strips. And then I'm going to draw in fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 8/5. If I shade them in, now I have, oh good, you guys can see it. 1, 2, 3, 4, 5, 5/5, 6/5, 7/5, 8/5. So this is the same as 1 whole, and this is 3/5. So 8/5 equals 1 3/5. Okay, let's do the last one. Ooh, what color am I going to pick? The lights went out and now I can't see. See if I wave my pencil. There we go. Okay, If I'm going to have sevenths, that means I have to have 7 little boxes. 1, 2, 3, and then I need 4. So I'm going to cut that in half and that in half. And that'll give me 4. Now I know if I have all 7 of these, if I have 7 out of 7, I don't need any more fraction strips. That's 7 out of 7. And that's the same thing as 1 whole. So 7 sevenths equals 1 whole. All right? So I hope this helped you to see and make models of improper fractions. There are going to be some times when we want to use improper fractions. So I hope you didn't get the idea that we never want to see them, because there are going to be some times when they're useful for us to use. And you'll see coming down the road that they can be useful. But we really would rather see this. We'd rather see a mixed number, because a mixed number is a little bit easier for us to visualize as human beings than if I say, hey, I want 5/4 of a pizza. That means you're going to have to buy me 1 whole pizza and 1/4 of another pizza, right? And you might not understand that unless I say it this way, because this makes more sense to us, right, than this. All right. Hope this helped you to understand improper fractions. And thanks for joining me, and I will see you later.